Hello, welcome back to another video. Today we're going to be talking about sort of longer problems involving a chain rule, quotient rule, product rule at the same time, just to show you that when the problems get tough, if you just follow your derivative rules, your normal algebra stuff, you can still get the answer pretty quickly. So let me just do this example and some other ones, and you'll see what I mean. So if we had something like this, 1/2 x squared multiplied by the root of 16 minus x squared, what would we do? Well, the first thing to realize is usually they're going to give you sort of a longer product or a longer quotient of two things. Now this is a product. We have one term here and then another term right here. So what we want to do is we want to just treat this like a normal thing. And remember, we have this product rule, which is f prime times g plus g prime times f. So this one right here would be like f, and this one right here would be like g. So if we wanted to follow the product rule, we would first take the derivative of this first function, f. So that would just be 1/2 the constant, bring down the 2, and then we're just going to decrease x's power by 1, which just turns it into 2x. Then we're going to multiply by just whatever g is normally, which is just 16 minus x squared. Then we're going to just go ahead and add the derivative of this one. So this one involves a chain rule. So it's important to realize that this is the same thing as 16 minus x squared to the 1/2 power. So when we want to take the chain rule of it, we just bring down the 1/2, and then we multiply by 16 minus x squared, and then we're going to decrease the power by 1, so 1/2 minus 2 over 2, or 1, will give you a negative 1/2. Then we're going to take the derivative of this inside part, so this would be just this negative x squared, so that'll be turning into negative 2x, bringing down the power, decreasing it by 1, and then we're going to multiply by just the f. So we took g prime, this was all g prime, and now we're going to just restate f. So that would be 1/2 x squared. So when we have it like this, we want to see if we can simplify any terms that may exist in it. And for now, I'll just go ahead and rewrite this for you first, and then we can do that. But I just wanted to tell you that you could simplify constants if you wanted to right now. It's totally up to you. So let's rewrite this then. So we know that easily, though, the 1/2 multiplied by the 2, that cancels. So we just have an x, and that's being multiplied by the 16 minus x squared root. So the same thing as before. And we know that this negative exponent means it's on the bottom. So we're just going to put a 1 for now, even though we know there are stuff on the top. But for now, let's just treat this as the root of 16 minus x squared on the bottom. And that's the same thing as the 1/2. And let's also put a 1 here. It's going to make it easier later on. So we took care of this root. We also have a half. So let's put that here. So the 1/2 is the same thing as this, the 1 over the 2. And we also have a negative 2x. So let's get rid of this 1 here. And then let's put the negative 2x on top. So the negative 2x on top of the fraction is the same thing as it being multiplied by this negative exponent. So we took care of the half, we took care of the negative 2x. Now we have this 1/2 here as well. So we kind of have two 1/2s. That's fine. We can have two 1/2s, and in fact, putting it like this is the same thing. So we have two 1/2s being multiplied. And we also have just an x squared as well. So we can put the 1/2 separated because this is like an invisible 1 here. This is still a half in front of the x squared technically. But if you notice, we can cancel out things, the constants here, some constants and stuff, before we simplify the whole term. And we could have done this up here, but sometimes it's easier to visualize it first right here. So we have a 2 and a 2, and they're all being multiplied. So we can just get rid of this 2 and the 2 here. It's still a negative x, but we got rid of the 2's. So what that leaves is a negative x right here, and the 2 actually still remains. So let's rewrite everything with some of that stuff simplified. So that would be x multiplied by 16 minus x squared. Remember, it's still over 1. And we have this negative exponent. So if we want to go to the side here, this is a negative x on top being multiplied by an x squared because we just got rid of the 2. So negative x multiplied by x squared, we know that's just x cubed, or negative x cubed. Apologies. So negative x cubed is on top. And we also have this 2 here. Now keep in mind, the 2, we can just put that in front of the exponent like this one was before it was canceled out. So that's 2 root 16 minus x squared. So now we've gotten rid of all the stuff that could have been multiplied or canceled from the top here. And now we have this fraction thing right here. Now what do we do now? Well, just as if you had another different fractions multiplied, we want to find a common denominator. So the common denominator between 1 and 2 root 16 minus x squared is 2 root 16 minus x squared. So we're going to multiply by the common denominator for all these terms here. So when we multiply by, this term will cancel out. So this one will be sort of canceled because we're going to combine them both into one fraction. So then we'll get that f prime of x, we're going to have a bunch of things, and they're all going to be over this 2 root 16 minus x squared, because that's what we wanted. We wanted to basically combine them both. Okay, so this one we know will stay the same. It's this one right here that's going to change, because this one doesn't have the denominator. So we're going to multiply this one by this one right here. Okay, so an x multiplied by 2 will just give us 2x. And then we have a root 16 minus x squared here, and we also have a 2 root 16 minus x squared here. So the roots will cancel, and we'll get that it's just going to be to the first power. And that's because we have a 1/2 here, and a 1/2 here, and a 1/2 multiplied by the 1/2, or adding because they're exponents, will give you 2 over 2. So then it turns into just 16 minus x squared. And remember, we also still have this negative x cubed here, which kind of just becomes, it carries over. So now this turns into something that's pretty doable from our starting place over here. So now we just have to simplify the top a little bit. So we want to distribute this 2x to these terms. So 2x multiplied by 16 would give you 32x. And 2x multiplied by x squared turns into basically 2x cubed, but we also know we have a negative still here, so negative 2x cubed. And then we also have just this negative x cubed here as well, so it's just carrying it over. And this is all over the 2 root 16 minus x squared still. Now we just want to go ahead and simplify these last terms on top, and we'll have the answer. So 32x, that stays the same. Negative 2x cubed minus x cubed just becomes negative 3x cubed. So negative 3x cubed. And this is all over 2 root 16 minus x squared. So this right here is the derivative for this top function. So if you notice, a lot of the work was actually just basically using a lot of algebra tools to combine it together and such, and the derivative stuff we stopped using up here. So this is one of the answers utilizing the product rule. I'll want to do one more after I erase. Okay, welcome back to another example. This one is going to involve the quotient rule and the chain rule instead of the first one, which was the product rule and the chain rule. These are usually the two combinations they'll give you. So we recognize right away this is a quotient rule. We have a quotient of two things. So this one right here would be f, and this one right here would be g. So remember, the quotient rule is going to be g multiplied by f prime minus f times g prime over g squared. So we're going to just turn this into the quotient rule just as you would normally. So the first thing to do is we're going to take the g function. So the g function, we're just going to rewrite it as it is. So that's x to the fourth plus 2. And then we're going to multiply that by the f prime. And we know that f prime, this is this one here, x's derivative is just 1. Then we're going to subtract f. And f is just simply going to be x, And then we have g prime. And if you remember from last time, we know that a root is the same thing as to the half power. So we're just going to put down the 1/2, and we're going to put the outer one first. So we're just rewriting this one. And then we're going to subtract 1/2 by 1 to get negative 1/2, just like the previous one. And then you multiply just by the other function over here. So the inner one would be x to the 4th, so its derivative would be 4x cubed. This is all going to be over this multiplication of the g squared. So g squared would just be this root x to the 4th plus 2 squared. So now this is the answer, and just like all quotient rule problems, we just have to simplify it. So knowing that, let's just start simplifying. So 1 times this would really just going to be root x to the 4th plus 2. And now we just want to rewrite this term as like we did before. We want to put this into a fractional form to better understand. So this is going to be 1 over this x to the 4th plus 2, and this is all going to be the root of it. And just like before too, we could get rid of some of these constants just already, but just because it's easier sometimes to see it in this way, let's go ahead and just put everything. So let's make this a little bit bigger, and we know there's a 1/2, so that's going to go right here. The 1 over 2 is the same thing. Let's get rid of the 1. And we know there's also an x here, so we're going to multiply by an x. So this one and this one is fine now. And we're also going to multiply by a 4x cubed. So like this. And then, keep in mind, we still have a minus here. So even though we've kind of separated the terms a little bit, there's still a minus separating them. And we also still have this root of x4 squared. But if you'd like, what we can do, since we know that if we square a root, it kind of undoes the root, we know this is technically just going to be x to the 4th plus 2. Okay, and keep in mind too, this is technically going to be a 1 here, just so it's easier to simplify later, but we really want to start working on this side first. So, simplifying the terms a bit, we know that over here, it's going to be a 4x cubed multiplied by an x, so that's going to be just 4x to the 4th. But then let's also understand that we're also basically going to have a 2 over here, so 4 divided by 2 is just 2, so really it's going to be 2x to the 4th. So 2x to the 4th is what's up here now, because we just divided by 2 and we multiplied by the x's, that's all we did. And then we're still going to have this root x to the 4th plus 2, and we're still going to have the subtraction of the root x4 plus 2 over the 1 all over x to the 4th plus 2. Now we have a complex fraction. Now to work with the complex fraction, we just have to get rid of this mini one. So the common denominator between this root here and 1 is the root x to the 4th plus 2. So we're going to multiply by the root of x to the 4th plus 2. So this one will cancel. This one will be multiplied to this top part here, and it will also be multiplied to this one down here. So let's go reflect that. So root x to the 4th plus 2 multiplied just by the root of x to the 4th plus 2 is just going to be x to the 4th plus 2, because again the roots canceled out. We still have this subtraction here. It's going to be minus 2x to the 4th, because this one it kind of just stays the same because it canceled. And then this one turns into x to the 4th plus 2 just multiplied by the root, and remember this is kind of one term, by the root of x to the 4th plus 2. Now we've almost finished. We just have to simplify some terms. So x to the 4th minus a 2x to the 4th is just going to be a negative x to the 4th, because there is this negative here sign here. So it turns into a negative x to the 4th. And this is still going to be a plus 2. Also keep in mind, this is technically the same thing to the first power is the same thing as 2 over 2, and this is the same thing as 1 over 2. Now if we multiply the exponents of 2 over 2, and we multiply them together, that's the same thing as like adding them. So 2 over 2 plus 1 over 2 is 3 over 2. So we actually can write this, if you wanted to make it cleaner, to x to the 4th plus 2 to the 3/2 power instead of just both of these. But both of them should work. So now let's just kind of go up here and rewrite our final answer. So your final answer is going to just be, we can rewrite it both ways. Usually teachers like you to put the negative sign in the middle, so we be 2 minus x to the 4th, same exact thing, all over x to the 4th plus 2 to the 3/2 power. So this was practice using more complicated derivatives involving the chain rule and quotient rule and the chain rule and product rule. I hope this was helpful and hope it helped you kind of see what harder ones, longer ones could look like. It's really not too bad once you just get used to the process of simplifying. Thanks for watching. I hope this helped.